Good morning, dear students. In the last class, we discussed about the circles chapter. In that, we derived one theorem, and I told that it is important for examination point of view. Okay, so now we'll go for the exercise of that topic of the chapter. So in that first problem, so how many tangents can a circle have? Suppose here we have suppose we have one circle here. For this circle, how many tangents we can draw? So we can draw infinitely many number of tangents. Infinite number of tangents we can draw to a given circle. Okay, so do we know what you mean by tangent? So tangent is a line which touches the circle at a single point, like this. At a single point it will touch the circle at only one point. Okay, here at this point. So at this point, like this, at a single point it will touch. So therefore, like this, how many we can draw? We can draw infinitely many number of tangents. So the answer for this is infinite number of tangents. Okay, so write the solution like this. So how many tangents can a circle have? So the answer is right, infinite number of tangents. Okay, you can draw a infinite number of tangents to a given circle. Okay, next, second main, fill in the blanks. A tangent to a circle intersect in dash points. So in how many points it will intersect? Yes, it's obviously, we know that just now I spoke about that. How many points? It is only 1 point. It will intersect at 1 point. Okay. Okay, next question. The a line intersecting a circle in 2 points is called a dash. So what is the line intersecting a circle in 2 points? Okay, I'll show you this. So you need to tell me. Okay, I can't hear you what to tell, but also you need to tell. Okay. Okay, now see here, this is a circle, right? Now what they're telling here, they're telling that the line intersecting a circle in 2 points. 2 points. So here it's 1 point, it touching here one circle, and also it touching a second point. So it intersecting at 2 points. So what is this called? Yes, it is nothing but, is it chord or secant? So it is secant. So this is secant. So what about this? So this line. So this line is chord. This line is secant. Okay. So therefore the answer. So you are intersecting at two different points. Okay. So the line intersecting a circle in 2 points is called a secant. Okay. So next term, a circle can have dash parallel tangents at most. So what is the parallel tangents? Okay. See that. So I'll draw one circle here. Okay. So now in this circle here, this is one tangent. Do you know what you mean by parallel lines? Okay, so here one circle. Okay, so it's a parallel. So how many parallel tangents it can have at the most? So it can have two parallel tangents at most. It can have two parallel tangents at most. Okay, so next, the common point of a tangent to a circle and the circle is called dash. Okay, actually I forgot to tell about this point in the previous class, previous video. So this is here, the tangent touching a circle at this point, right? Okay, at this point it is touching a circle. So this point, just at this point it is touching a circle. So actually this point where the tangent touches a circle, that point is known as point of contact. Point of contact. This point is known as point of contact. Even this is also point of contact. This is also point of contact. This is also point of contact, and this is also point of contact. So point of contact is a line or a dot which touches the circle at that point. So you can call this as a point of contact. Point of contact. Is it clear? So next main. So next question. A tangent PQ at a point P of a circle of radius 5 cm meet a line through the center O at a point Q, and so that OQ is equal to 12 centimeter. So then what is the length of PQ they are asking. Okay, so actually we need to solve the problem. We need to solve the problem for this. We're not able to guess the answer. Okay, so how to solve the problem? So first, to solve this, we need to draw the diagram. Okay, I'll tell you how to draw the diagram. Okay, now what they're telling, draw a circle first draw a circle. Okay, this is a circle. Okay, then this is the center of the circle. Okay, now take one radius. So here a tangent tangent PQ at a point P of radius 5 centimeter. So here this is a radius. So this is the radius of 5 centimeter. This is the radius of 5 centimeter. Okay, a tangent PQ. So you can take this as P. Okay, P. Okay, radius of 5 centimeter. Meet through a center. Okay, at O. Meet the center O at Q. So that OQ. So this is O. This is O. Okay, so this is OQ. OQ which is equals to 12 centimeter. So this is Q. Now this is a line segment which is touching at this point. Okay, OQ. So now here what is that? OQ which is equals to 12 centimeter. And just do you know why this problem they gave? Because in the theorem 1 what you learnt, so any line that is withdrawn from the center to the tangent is perpendicular. To recall this concept they give this. So if it is perpendicular, then what type of triangle it is now? OPQ is what type of triangle? OPQ. Triangle OPQ is which is equals to right angle triangle, right? Right triangle. Triangle OPQ which is equals to right triangle. Okay, now here OP. What is it? No, this is radius. OP which is equals to 5 centimeters. So then what is PQ? We need to find. Okay, we know that. So in the right angle triangle, if we know the two sides, so we can find the third side by using the Pythagoras theorem. So do you know what is Pythagoras theorem states? The square of hypotenuse. This is the hypotenuse side. OQ is hypotenuse side. The square of hypotenuse is equal to sum and square of other two sides. So therefore we can write, according to Pythagoras theorem, OQ square of hypotenuse is equals to sum OP square plus PQ square. The square of hypotenuse is equal to sum and square of other two sides. So therefore here OP square is 12 square, which is equal to OP square is 5 square plus PQ square. Okay, where P what is that? 12 square. What is 12 square? 12 into 12. It is 144, which is equals to 25 plus PQ square. So therefore 144 minus 25, which is equals to PQ square. So what is 144 minus 25? 144 minus 25 is nothing but 119, which is equal to PQ square, isn't? So therefore PQ which is equals to square root of 119 centimeter. Square root of 119 centimeter. So therefore option D is the correct answer. I hope all of you understood. Yes, in the classwork you need to draw this diagram. Along with the diagram, do this calculation. Then you write the option D. Okay. So next problem. So now what they give you? So they give that draw a circle and two lines parallel to a given line, such that one is tangent and the other is secant to a circle. Okay, now what to do? So you can draw this using your pencils, okay, in your classwork. So consider it and no need to take any measurement. So just take an approximate measurement. So no need to take the exact 3 centimeter radius, 2 centimeter like that. Don't want to take. So take a small measurement. So draw a circle with any measurement. Okay. For better you can draw a small circle. So consider a circle with center O. So why I told, because because they not yet mentioned anything. So what is the radius of the circle, anything they not yet mentioned, we can take according to our wish. Okay, now here consider circle with center O. So let AB is the given line. Okay, AB is the given line. So next what you can do, so you can draw one perpendicular line for that AB. In the last year we discussed about how to draw the perpendicular lines. So how, in the sense, so take more than half of AB and cut arc on both the side, both on upside and downside, and with the same radius with the center B, cut that arcs. So you will get the uh, you'll get like this. So we'll get like this. So now draw a perpendicular from O to AB. To AB, draw a perpendicular like this. AB, which is intersect at intersect at, just a minute, intersect at intersect AB at P. Okay, so at P it should intersect. Okay, so then what to do next? So now what to do? Now take 2 points on PQ. Okay, on one circle at X and Y. Okay, so then now what to do? So now draw a perpendicular from O to the line AB which intersect AB at P. I told you how to draw the perpendicular lines in the last year, and also we constructed many perpendicular lines in the previous year. So how, in the sense, from the A, so take more than half, and from B take more than half, from A take more than half and cut the arc on both the side, and from B also take the same measurement, cut that arcs. So first draw the arcs on both the side, and with the same measurement with the B as center, cut the arcs. So and afterwards you can join this. So this is a perpendicular line how we need to draw. So next step is, so what we need to do, we need to do that we should draw one tangent and one secant to this one. So how to do this now? So next so now take 2 points on the line line PQ, one at circle X and another Y inside the circle. So draw a line parallel to AB passing through X and Y. CD and EF are the required lines. So here CD is the tangent, EF is a secant. Okay, so like this we need to draw. So this construction and all I explained theoretically, but theoretically we not able to. So now next step what we should to do. So now take 2 points on the line PQ. So one at a circle X and another Y inside a circle. So draw a line parallel to AB and pass through X and Y, and CD and EF for the required lines. And this problem, especially this problem, this is we not able to explain theoretically. We need to do it practically using a compass and protractor, but here that is not possible to do. So now do one thing. So write this as it is and practice these problems. So later when we come to the classrooms, so we'll discuss about this problem once again. Okay, fine. Okay, now here the number of tangents. So next concept is the number of tangent from a point on a circle. So from a one point, how many tangents we can draw? So to get an idea of a number of tangents from a point on a circle, let us perform one activity. Okay, now for this activity, do one thing: take one rough sheet and take one compass, pencil. So get ready with all those things. Okay, now activity is like this. So draw a circle on a paper. Okay, take on any measurement and draw a circle on the paper. So take a point P, inside it can you draw a tangent to the circle through this point? You will find that all the lines through this point intersect the circle in 2 points, isn't? See here, we're not able to draw a circle at this point, so it is not possible to draw a tangent to a circle, a point inside it. Suppose the summary of this is simple. So if we have a point inside, point of contact P, we have inside, we're not able to draw the tangent. Okay, that is finished. So next case, what they did here, next take a point P on the circle and draw a tangent through this point you have already observed that there is only one tangent to a circle at the first point C. So here if we take the point outside, that is on the circle, so therefore we can write that as P is the tangent. So next, finally take a point P outside the circle. So we can draw only one tangent when we take on the circle. Suppose here if we take inside the circle, we are not able to draw any tangents. If we take a point on the circle, we can draw one tangent. Suppose if we take a point P on outside the circle, there you can draw a two tangents. Are you getting? It's very simple. Suppose here we have one circle here. So your point of contact is point of contact P is inside the circle. So then we not able to draw any tangents. Suppose point of contact P is outside the on the circle. So on that time we can draw one tangent. Only one tangent we can draw. Suppose we have the point of contact outside the circle. Suppose somewhere here. So then we can draw two tangents. So this is a summary. So we summarize this fact as there is no tangent to a circle passed through a point lying inside the circle. There is only one tangent, one and only one tangent to circle passed through a point lying inside the circle. So there are exactly two tangents to be circle, a point lying outside the circle. Okay, this is the summary of this. So why they give this concept in a sense? So next why they give this concept in a sense? Because next they're going to derive the theorem, and the next theorem is very important as a examination point of view, and no need to write this in the classwork. So just okay, do one thing. In the classwork you write like this. So first you write this heading, the number of tangent from a point of contact on a circle. So first write this heading. After writing this heading, we come for this. So don't write case 1, just write 1 2 3 and write that points. There for 1 you write that okay, now what to do? Okay, write this 3. Okay, write this case 1, case 2, case 3 only. And also you need to draw this diagrams. For after drawing case 1, so draw this diagram, and after drawing case 2, draw this diagram, and after writing case 3, draw this diagram. Okay, I hope all of you understood. Okay, I hope all of you do these problems, and that's how and we'll complete the class works. Okay, so then next we'll see the remaining thing in the next class. So next class I'm going to teach you a theorem, and that is very important as a examination point of view. Okay, compulsorily that theorem will come for 3 marks. I told that in this chapter we have only two theorems. One is first one what you learnt in the last class, so that we can expect around 20%. But the next theorem what we're going to do, what we're going to derive tomorrow in the next class, so we're going to expect about 80% or 90% we can expect the question. In this year also the same question appears, and from last 4 to 5 years the same question is repeating for 3 marks. So next theorem is important. Okay, so now so far, so complete this classwork and see whatever I gave this right in the classwork once. Okay, and also practice the in the homework, write that theorem 1 2 times in the homework. That is your homework today. Okay, your homework is write the theorem 2 times in the homework book. Okay, so then remaining thing we'll see in the next class. Thank you, have a great day, bye.